I just want to make sure that the test going to be on next Saturday. Yes. Oh, am I muted? No, I think I'm still talking. Correct? Am I muted?
We can hear you, yeah.
All right. Okay. Okay. So that's fantastic. Um, so let me just double check that real quick for that. So the test gonna be on September 24. Right? It's gonna be on Saturday, September 24. So let me just go to that assignment real quick. Okay. It should be on September 24, and it will be at 9:10 p.m., 9:10 a.m. until I would say an hours and 50 minutes. So I can make it start at 10, and then we're gonna finish it by 11:15. Okay. Okay. Oops, 11:15 a.m. All right, and then I'm gonna set the password for that, and make sure that we need to download the lockdown browser. So it's a requirement for this class. I really don't want to use it, but still, this is part of the process. So I really want to make sure that people use the lockdown browsers for that. So make sure that we're not gonna go away from the screen. But I think you can use note. If you take notes, it should be okay. But anyhow, so I hope that all of you are doing fantastic. So make sure that the test's gonna be on September 24. Okay, September 24. Test one, which is exam joint. So that's gonna be September 24. Okay, and the times will be from um, 10 a.m. until 11:15 a.m. Okay. And I will tell us what to do when we take the test. Okay, I will tell you what to do when we take the test, and then you know, and that's pretty much what we have to get it done. Is make sure that you are able to download the lockdown browsers for that reason. So let me just double check that for you guys. Browsers and download. So,
Get more sugar.
yeah.
Get more sugar.
Oh, yes. Yeah, of course. I want sure for that. Let me just. I'm sorry about this. Okay, so let's get started for the rest of the objective two, and I hope that everybody is doing fantastic today. Okay. Yes, we will. We have to be on Zoom first. We have to be on Zoom because the test going to be at 10 a.m. in the morning. I really need you guys to come to Zoom so that the first thing I'm going to do, I'm going to take attendance as part of your educated points. And then the second thing I'm going to do will be asking, we're going to telling you some of the things that you have to remember. You have to know what it is for the test. Okay, that's really important. All right, so now the thing that we're going to do for today, which topic that we finish? So I think that we finished the STEM and leap, right? Did we finish this? Which one do we have started? Let me just check. I think that we stopped at this topic, correct? So we stop at the proportion statistics. So that's going to be a things. And then let's start with new topics. So the salary of the employees at full company are summarized below. Answer the question about them. So the range salary is 37,000 and then the mean salary 40K. That's part B, 46K, and then the mean salary is 34,000. The C, 41K, and then the mean salary is 33K, so on and so forth. So based on the information above, which company salary have the most variability? Yes? People?
Is it company B?
Is that company B? Yes, that's correct. So variability, meaning that, so we're gonna go for objective 2, continue. So the variability, meaning that it have a big range. Okay, so the bigger the range, the more variable that data set will be. So B will be the correct answers. Okay, and then based on information which has a lowest salary on average, so the lowest salary should be 31,000. Are we good? So that should be D. Is that good, people? Is that good? We solve it. Okay. Are we good with this question? Can we move up to the next one? Yes. All right. Fantastic. Remember that we just B for range represent the variability. So how much your data set going to be fluctuated. Okay. So now we're going to move up to the next questions where we're going to compare.
Joseph,
Yeah.
sorry, I didn't understand. Why is B? Why is not A?
Okay. Let me go back to the question one more time. So let's say I got a new question. So which one gonna be the correct answer? So they have the range salary would be 45K, 36, 40,000, 38. Which one has I'm sorry, the average, which one had the lowest average? A, B, C, D.
C.
Yeah, C, because we have the mean salary of 28,000, C, correct? Which one has the, which company has the most variability?
A.
A, because A going to give you 45K, right? So let's say we choose D, so then see how the question is going to get solved. Is that good? C and A. Okay. Is that good? Yeah. So the A, the company A has the most variability, and then the company C actually has the lowest salary on average. Okay. Okay, so now we're gonna move to the next questions. That's really important. So the mean, median, and range, and then the IQR. So this is the part that we definitely have to go over. Okay, so we need to know how to find the final summary. So final summary is very, very important. So so final summary. Okay, so assuming that we take one example. Okay, so we take like 5, and then 7, and then 10, and then 12, and then 15, and then 25. Okay, so just assuming that we have all of this. Assuming that we have all of this data set, so and then we're gonna give it like 35, and then let's say 60, okay, whatever it is. So now we need to understand how to let's say take one more data set, let's say 75, whatever it is. Hold on a second. Okay, so now what we need to do is that we go into look for the final summary. Final summary meaning that we're going to find Q1, Q2, and Q3. Okay, so Q1 will be the first 25 percentile. Okay, so what does that mean? Is that, let's say we're gonna have 100 percentiles. So we're gonna divide the data set into 100 percentile. Okay, and then what's going on for that is the first data set values going to be the smallest. Okay, so this one going to be the smallest. and this one gonna be the biggest. Okay, so this one gonna be the biggest data set point. So make sure that we knew what it is. And then the next thing that we need to do is that we need to look for Q2. So we're gonna, what is the Q2 for this? The Q2, which is called the median.
Median.
Yes, very good. So Q2 will be called a median. So meaning that it's going to be like a middle number between the smallest and the biggest data set point. It's just like the entire data set. That is the middle number for the entire data set point. So it's gonna divide the whole thing into 50 and 50. Okay, so that's very important. So on the other hand, that we're going to look for Q1 and Q3 respectively. So the Q1 that we have here, so the Q1 will be gonna break the data sets into 25 and 25. So this will be another medians between the smallest and the Q2, okay? And then the Q3 on the other hand is going to be the median between the Q2 and the biggest data set. So basically what we need to do, we need to find 3 middle data set point. Okay, let me just write them down. Q2 gonna be the middle number for the entire data, okay? For the entire data set. And then Q1s and Q3s. So Q1's gonna be the middle numbers for from smallest to Q2. And we also have Q3, which is the middle number from the Q2 to the biggest data set point. And then, but we need to be careful with all of this part. We do have a certain exception that we have to get it done now. So let's say I want, and then we also call another thing that we call the IQR. It's IQR, which is called the interquartile range. So the interquartile range, so this one, let me just put that a formula first. That will be Q3 minus Q1. Okay, so of course that you're gonna be given by the formulas like that. And then this is what we call the IQR. It's just literally gonna be the middle chunk, the middle half of your 50 percentiles. Okay, so that's started from Q1 and then ended by Q3. So in other words, when you're taking a difference between Q3 and Q1, we call the IQR. So the IQR is short for interquartile range, okay? All right, so now the thing is that the next thing is that we're gonna look for the lower fence. Why we have to look for the lower fence or the lower boundary? So the text, they use the boundary for that. Well, I mean, I'm using fence. So the lower boundaries at the lower fence that we going to compute it by the Q1 minus 1.5 times the IQR. So that's really important. But you don't necessarily have to memorize these formulas because the question is going to give you that. And then we also have the upper fence. Upper fence is going to be the Q3 plus 1.5 times the IQR. So the most important thing that we need to know about those two is that we're going to set the fence. We're going to set up the upper and the lower fence. Any value that not in this range of not in the range of the lower and in the upper fence will be called the outliers. Okay, so so let me just write it down right here. Any numbers, any data not in the range of the fence. So we're going to call them we're going to call them the outliers. Okay, so they are the outliers. So we definitely going to have some questions asked as you do this question on the test, and then we're definitely going to go through a few examples and see where it goes. So the very important thing that we need to understand is that we're going to pick what is the middle number for this data set points. The middle number will be equal to 15. Are we good? So that's going to be that's going to be the middle number. So we call this middle number as Q2. Are we good with this question? Is that good? Okay. So, and then after that, we're going to cross out. So if there are only one middle numbers, all we need to do is just cross out 15. And then we're gonna look for Q1. So remember, if you only have one middle data set, we're gonna cross them out. and then we're gonna find the Q1 and Q3 respectively. So what are the middle numbers between 5, 7, 10, and 12? So that should be 7 and 10, right? So we need to look for the middle number between 5, 7, 10, and 2. If there are two middle numbers, so the Q1's going to be 7 plus 10 over 2. Are we good? So we're gonna get 7 plus 10, and then we divide it by 2. So the Q1 will be 8.5. Any question with this? And then the Q3 will be the middle numbers. So that will be the middle number from 25 to 75. So we do not really count 15 when we look for Q3. So apparently that we need to add 35 and 40 together. So in this case, the Q3 that we got here will be 35 plus 40 over 2. Is that good, people? Over 2. And then that will be 72 over 2. I'm sorry, 75 over 2 will be 37.5. Are we good? Are we good with that question? So so it's so important that we understand about the fact that if the mean equal to the median, so you got to be careful. If the mean equal to the medians, what happened to your data set? The data is symmetrical. Okay, symmetrical. So we have to put it down. If the mean is not equal to the median, so that is not symmetrical. Okay, so we have to make sure that the data equal to the median. So I'm sorry, the mean is equal to median, so that is symmetrical. So now we're going to read the question for that. A fishing tournament was held last year at the fishing academies. The organizers recorded the weight of each of the 72 fish caught. The smallest weight was 20 pounds, the largest was 27 pounds. The chart, the table gives the mean, the median range, in the quartile range. Yes, we definitely gonna go to it. You have to give me some time, Charlotte. I can't really finish everything at once. It's gonna take some time to finish all of this topic first before I can go to the data day, right? And then the data day is gonna be due like the next 2 weeks. It's gonna be on next the following Saturday. It will be due on October 1st. Okay, so we have a bunch of time to get it done. So so select the best description of spread for the data set. The spread of the data set will be
The range in the IQR.
yes. So what can you tell? But it doesn't really give us the range. So it's going to tell us the spread of them based on the IQR as well. So the spread is actually coming from the IQR. So we can see that B should be the correct answer. Are we good? Is that good, people? Okay, so and then the second thing is I select the best description of sender for the data set. So the average based on the median should be around 22, 23, and 24. Are we good with this? So select a graph with a shape that best fits the summary value. So graph 1, the data set is not symmetric. Graph 2, the data set is symmetric. So we can definitely gonna check the mean equal to the median. So there should be a symmetrical. Okay, so we can go graph 2. Are we good? We solve for it, right? So let me just try the wrong answers and then let the software solve for it. Okay, is that good?
I think that's the only thing I don't understand when you go
Which
to
one?
the graph. I get
So-
everything else but the graph.
Right. So the most important thing we need to understand is that if the mean equal to the medians, then the data is symmetrical. If the mean is not equal to the medians, so it's not equal to the medians, so we just say the data is not symmetrical, as simple as that, okay?
Oh, okay. Thank you. Thank you.
You're welcome. You need one more try or we good to go?
No, I'm
Try.
good. Thank you.
I'm sorry?
One more try.
One more try. All right, so we do the same question. So the mean equal to the medians. If they're not equal, so we just put down not symmetric. It's okay, not symmetric. So the same thing for that. We have like I don't care. So now select what is the center for the data set? The center should be 10. Are we good? So that should be A. Are we good with this? Is that good, people?
Yes.
Okay, so part B, select the best description of spread. For the spread should be either the range or the IQR. So in this case should be IQR. The spread represent the middle half of the data set. This is what I pointed out, right? Correct? Are we good? Are we good? So what can you tell about whether or not the graph is symmetrical or not symmetrical? It should be symmetrical because the mean equal to the medians, correct? Should be graphed here. Are we good with this?
Yeah.
All right, so should we move up to the next question?
Next.
Yes, Professor, but please, before that, could you go to the notes? I want to get something, please.
Okay,
Thank you.
the note is posted after class, so it's under the lecture notes. Yeah. Is that good? Okay. I'm gonna give you another 30 seconds to copy down the notes.
That's good. Thank you.
You're very welcome. So now we're gonna move to the next topic where we're gonna use Stanley Leap to complete the data set point. Right, so the Stanley Leap is relatively straightforward, but let me just copy that down and then show you what it is. Okay. And then what a question is going to ask, let me just answer some on this side so it doesn't necessarily going to cost me more space to answer this question. So what the question is asking to do, so the question is asking us what is the ranges for the two groups, okay? What are the ranges for those two groups? So we need to look for the range, so the graduate and then the non-graduate student. So the number of hours at work, so how long they have to work per week or per month, I'm not sure, did they say? Last week, okay, per week. So so in this question, apparently that we have two Stanley Leap plot, are we good? So the middle ones here we call the stem. Are we good? The stem is basically the 10-digit numbers. Okay, so and other than that, the non-graduate gonna be the leaf. Are we good with this? So let's say we can read them. So 22, 3 will be 23. Okay, 2, 3 on the left gonna be the 23 for the graduate, and then 2, 4 on the right will be 24 for the non-graduate. So apparently that the smallest number should be started from 2. The biggest number should be started from 5. So the smallest number for the graduate should be what? The smallest for graduate will be? Anyone please help?
34? No, 23.
23, very good. And then what is the biggest number for the graduates?
53.
53.
Very, very good. Okay, so that would be 53. So we can definitely gonna figure out the range for this. So the range is the high minus low, right? Is biggest subtract the smallest. So definitely gonna give the answers is equal to 30. Correct? Are we good? Are we good with that? And then the same thing for the smallest for non-graduate. And then we definitely gonna see that the answers were I'm sorry, there's a little things here. The non-graduate, the small for non-graduate 24. Are we good? And then the biggest for non-graduate is 58, and then we can subtract them. The ranges will be 54, 58 minus 24 should be 34. Okay, so that's basically the things that we need to fill them out for the Stanley plot is relatively straightforward. And then which group has a high median number of hours? So how can we find a median? It seems to be really hard. So in order to find a mean for the graduate, when you look at this, so we have to pick a middle number, correct? So we're gonna go and cost out. We're gonna cost out with 3 numbers, and then the first, and then another 4. We're gonna cost out with those 4. Okay, so the medians for this should be between those 2 numbers for the graduate. So the medians will be 35 or 37. So the median for graduate will be 36. The same thing. So the first 2 numbers here, we're gonna cost with those 2. And then the next 2 gonna overlap with those. And then the next 3 gonna overlap with these 3. Sorry. Yes, so, and then the median should be between something, right? Should be 41 for that part, right? So you can actually do that, or you can write up a data set and figure out what the median numbers for all of this, correct? So it's gonna take some time to get it done, whatever the strategy that you apply. So it should come out with the correct answer. So which one has a high median number of errors? So apparently that we're going to have a non-graduate, correct? Is that good? Which group has more responses than 50? So apparently that the non-graduate is going to have more responses because they have 50, 50, 53, and 58. So they have more responses. Are we good with this, people? Need my help?
Good.
Okay, so could we move up to the next topic? Are we good? Could we move up to the next topic, or we need to try another question? Okay. Okay. So it should be straightforward. The only thing that is harder to find in medians is like basically you have to find the middle numbers. Okay, so we have a list of numbers. You're not going to list them, and then so you got to be careful when we try to solve this question. But generally, this is what we have, and then we move up to the next question. Let's see what's going on. All right, and then population standard deviation. Okay. We have 6 participants, weight loss class, loss of falling weights after 3 weeks of dieting. So we want to send the data. So I want you to find a population standard deviation. So let me just give you the formula real quick. So the population standard deviations, the standard deviation is literally the spread, represent the spread of the data set point. So in order to look for the population standard deviation, so we're gonna do the following, okay? So first, we need to take the square root of the entire things. And so in other words, it had 2 forms for it. So but we're not gonna spend too much time working on the form. So we have to divide by n for this part. And then we're gonna see some of the very, very crazy letters. So that will be the summation. So I'm not sure that you love this one, but it's very, 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 very hard to understand. And then we're gonna take the xi minus x bars, or which is minus the means, and then the square, and then you're gonna square them. Okay. So this is what we usually have to get it done, but it's gonna take too much time for it. Okay, so in other words, the standard deviation is just basically the average deviation of a data set point. And then we can also read the explanation when you go over the chapter, but definitely we need to compute it. We need to compute that. So this is what we have for the population standard deviation for this. Okay, so we have to divide it by big N. The N represent the population size. So this one, okay, this one meaning that we're gonna add them up, right? So we're gonna add up. This is what we call summation. Summation meaning we're gonna add up everything. Okay, add up from 1 to n, whatever it is. Okay, so now I feel like this form is a little bit too hard to compute it. So I made up my mind and then give you another competition formula. So we can use this formula on a test, and this one should be something that we go into involving. with the summations one more times, but we can get it done on a calculator, relatively easy. And then the summation that we have will be x squared, will be the data set value squared, minus the sums. So this is what we call a computational formula. So we can do it that way, minus the sum, because I need some space for that. Okay, so minus the sum square. Okay, I can't really draw it well for some reason. So let me just draw this right there. Minus the sum square. X squared. So we're going to square them. Okay. Over n divided by n. So we have to divide it by n first here. And then after that, I'm going to divide it by n. So it seems to be really hard for me to draw. I would like to go with it. Okay. So it doesn't bother you that much, correct? Because I can draw well on them. On my notes, so I just say the computational.
Did we go over introduction to summation notation?
Summation and notation. I will show you how to get it done on a calculator, okay? Computational standard
Yeah,
deviation.
because we're not allowed to go to the topic gear up to unless we do that part first.
But you can't get to the you can
Yeah,
get to,
it says in order to do population.
yeah, it gives you a list of forms, which is something that we have right there.
Yeah.
And then but I feel like this one is actually relatively hard to do the competitions, which is that one, which is something that just put it down here, publish standard deviations. We use this syntax, and then but I feel like it's actually relatively hard to compute a population standard deviation that way. So in other words, I use the population formulas. I believe it's easier to get it done. It's actually so much easier. And so let me just copy and paste and see what it is. So, okay, so that seems a little bit easier for me to use those two. Okay, so population standard deviation. Okay, no, this is not a competition forms. I need the competition forms for this. Yes, that one. And then yes, so I actually need those. Okay, so that would be easy to see them. But this questions, is that good? And then I need to take one example, correct? So we take one example on the on here, and then you're gonna go back there. So we're gonna send the list to the calculators. Okay. The first thing that we need to do, you're gonna send a list to the calculators. Okay. Are we good? And then the first thing that we need to do, we need to take care of the sum of x squared. Okay, the sum of x squared. So we need to find them on the calculators. How can we do the sum of x squared? We're going to do this. Okay, and then so you have to hit this one, and then you press equal. So we're gonna get 82. Are we good? So this is what we call a sum square. Is that good, people? Is that good? You want me to do that one more time? So let me just try it one more time. Send it data to the calculator. And then it's getting codes. And then we're gonna hit that one. Okay. And then after that, I'm gonna hit equal. So we got 82. Thank you, George. So this is what we got. Okay, and after that, we're going to do the x, the sum of x. So we need to look for the sum of x, which is something that we have here. And then we're gonna compute it. Okay, so how can you compute the sum of x? So it's very straightforward. Again, that we're gonna use the syntax. You see a little symbols here. So you just take the sum. So that would be equal to 18. Are we good? Are we good with that? Here's the sum. And then we need to look for standard deviations, population standard deviation, which is the syntax. And then we go into do the math. We're gonna take the square root. Okay, take the square in a calculator. Okay, we're gonna take the sum. You see that the first one always be the sum. So we're gonna put that 82. Okay, 82 minus. So remember that on top of that, you subtract this. You subtract the sum square. I'm sorry, this is a square of a sum. I apologize. This is a square of a sum, so we have to square the sums here. So we're going to take 18 square over n. How many data set point? So we look at that example. So we have 6 of them. So n equal to 6. Okay, n equal to 6. So that means that we're going to divide it by 6. And then also after this, we're going to divide everything by 6. Is that good? Is that good, people?
Yes.
Okay, so but the thing is, how can we do this calculations on the calculators? So that's going to take another question. So of course, let me just copy that question first, and then I just want to know that. Well, this is what we're trying to compute. So we're trying to look for these 4 data sets for population standard deviations, or 6 data sets for population standard deviations. And then, so the data is right here. Okay, so, and then how can we actually compute this on the calculators? So we're gonna cost them out, right? And then we're going to do, we're gonna take the square root first, right? And then we're gonna open the parentheses. Okay, and then we're going to put down 82. So 82 minus, so you can see that this one will be 18 square over 6. So that would be 18 square. And then when you do that, I'm gonna divide it by 6. Okay, is that good? And after that, I'm gonna close parentheses. And then you have to put the divide right here, okay, divide. And then you have to divide it by -6. Are we good? Everybody see that? Everybody see that the entire calculation that we do on a calculator? Okay, so you hit, the answer will be 2.16. Okay. 2.16. And are we good? Can check. Okay. I solve it. I saw you solve it. Okay. Are we good with this question? So we can try another one.
Can we do another one on the calculator?
Absolutely. So so make sure that we're going to use the formulas that we have here for the population standard deviation. So let me just copy that out and put it to the other page. Okay, so that we don't forget it. Okay, so what I'm going to do, I just simply use the calculators. Is that fair? Let's simply just use the calculator so you can see what it is. So I'm gonna send the data set to the calculator first. You're gonna hit this guy, hit x squared, the sum of x squared. So you're gonna see the sum square here, and then you're gonna press equal. So you got 316. Are we good? So first, then we're gonna write up the data set. So the sum will be 316. The sum square, it will be 316. Just write them down. 316. And then after that, you're gonna close the calculator. So you're gonna use that one more times, and then just heat the sum. So heat the sum should be the next function on the left of the sum square. So this is, we have a little sum symbol right here, and then you're gonna press equals. It's just add them up. You got sums will be 42. Okay. So that one's 42. Okay, so are we good with this? Are we good? Is that good, people? Are we here with those two? So now we're gonna use a calculator for that, right? So first, I'm gonna do that one more times. And then you're gonna just take the square root, right? You take the sum. So the sum square with 316. So first you have to open the parentheses. Okay, open the parentheses on your laptop. So we're gonna take 316, okay, minus what? Minus the sum squared. So we're gonna have to do like 42 square. So how can you do the square? You're gonna hit this one, or you can just use a little hat on your laptop, and then you're gonna get out of there. You have to get out. You have to use an arrow on your function, the arrow functions on your laptop, and then you're gonna hit divide. Okay, you're gonna hit divide by 6 because we have 6 data set point. And then after that, you're gonna get out one more time. You have to get to the right, you close parentheses, and then you have to hit divide one more times, and then you're gonna hit 6. And then you're gonna get the answer, which is 1.914. Is that good? Are we good with this? Is that good? You want me to do that one more time?
Can we try another one?
1.91. Okay.
When I'm
Alright.
making the divide for the last n, it won't let me do it in
No,
the.
you can. You use a little. You see your keyboard. It has like the dash, which is we have a question mark on top of that, and so this is what we call the division. Okay. So let me just do that one more time to see how we're gonna get it out. How I have to only try 2 or 3 examples. That's it. And then next we're gonna go for the sample standard deviations, which is slightly different. I will show you how to get it done as well. So just I'm gonna do it this example, and then I have to move on to the next question. Okay, so let me do that one more time. So I need to take 316, open the parenthesis first. 316 minus the sum will be 42, and then you're gonna hit the square. You can use a little hat on your calculators, and then you have to get out. You have to get out before you can divide it by 6. See that? And then you have to get out one more time. You have to get out of the denominator. So you close the parentheses, and then you divide it by 6 one more times. Is that good? Is that good, people? Is that good? And then let me just share how to do it. Okay, this is what you see on the calculators. And then you're gonna hit equal, so the answer will be 1.91. Okay. All right. So I do not have time to show you another one, but you're definitely gonna see the standard deviations for the samples, and then I show you this. Pretty much the same thing. But the sample standard deviation is just divided by n-1. Okay, I'm gonna do it next. Is that good? Okay. Are we here with that question? All right. Okay, so let's go to the next ones. I believe it's a little thing. So we okay. I need to close this browsers and then go to Alex. Okay, so now we're gonna go for sample standard deviation. So it's pretty much the same thing, but I'm gonna show you another trial to get it done. So for the sample standard deviations, we're gonna go for the computational for sample standard deviation. Okay, let me see what it is. Frequency distribution, blah blah blah. I feel like yeah, so that one's gonna be the opens. Okay, let's see what it is. Okay, so Yes, calculating a form, so we can definitely gonna check that the sample standard deviations. It's just like that. Let me just copy that as forms and show us how to get it done. Okay. So the sample standard deviations will be called S. This is what we call the sample standard deviation. And how can we compute it? It's literally going to be the same way that we can do. So this is what we call sample standard deviation. And then all we need to do is just taking the square root of that. And then we're going to do the sums. This is what we have to understand the concept. We're going to take the x minus the mean. So x minus the means. Okay, so we call it deviation. So the mean we call x bar. We do not use a little syntax right there. For the population, we just square them. And then you're going to divide it by n minus 1. Okay, so we have to divide it by n minus 1 to get it done, because that would be a big difference between the sample standard deviation and population standard deviation. All right, so so the difference between the population and sample, just we have to divide it by n minus 1 instead of n for the last part. So and then we're gonna take the square root at the end, and that's pretty much what we have to get it done. So for this experiments, we're gonna do pretty much same thing. So let me just copy that the questions and put it on a note so we can have something to look at and see what it is. Okay, so let me just put the question right there. Okay, so we have n equal to 5. And then, so I want to compute a sample standard deviations. The first thing I need to do is that I need to find, again, that the sum square one more time. So we're gonna send all of this on a calculator, okay? On a calculator. So the sum square relatively just a 2 sentence. I'm sorry, just a few click. Okay, so first you're gonna send the data to the calculator, right? And then after that, gonna hit the syntax, right? So there's the sum x square. We call it sum square, and then gonna hit equal. Are we good? So we get this 1A4, AA4. Am I going too fast for this? Are we good with this questions?
Yeah.
Okay, so the next thing that we need to do, close the calculator, send the data to the calculator one time. You're not gonna rewrite them, it's just too much. And then you hit the sums. So the sum will be 150, okay? Are we good? Are we good with that? Okay, so then we're gonna take the form in this case. So remember, you have to read the question. The question is basically look for the sample. This is a sample standard deviation. So we're gonna pretty much doing the same thing. You're gonna take the square root first, and then open the parentheses and put down the sum. The sum square that we have is 4AA4 minus, I'm sorry, minus the square of the sum. So the sum that we have is 150, so we have to square them. In this case, so we have to take 150, you're gonna hit shift, hit 6, right? You're gonna raise the power, and then you're gonna hit the square. You have to get out. You have to get out. If you don't get out, just keep doing on the top, right? On the exponent. So once you get out, and then you divide it by, you have 5 data sets. So n equal to 5, so we have to divide it by 5, right? Are we good? And then you have to close parentheses. Why we have to close parentheses? Because once we close parentheses, you have to hit the division one more times. So we have to divide by 4. Remember, for the sample standard deviation, we have to divide it by n minus 1 instead of we divide it by n. So that is, but so what that means, we have to divide it by 4 instead. Okay, I'm so sorry about that. I need to mute. If you want to answer the question, let me know. And then I'm gonna hit equal. So we're gonna get 9.79. Are we good? Is that good, people? So let me do that one more time. So just want to make sure that people get it. So first, I'm gonna take this, the sum square. So the sum square 4AA4, right? So I just take 4AA4 minus 150 square, get out, divided by 5, because we have 5 data set point, get out, divided by 6. Sorry, divided by 4, you have to take 1, right? So n minus 1, 5 minus 1. So you have to divide it by 4. And then, so we're going to get a final answers. Are we good? Is that good, people? So we got 9.79.
Wait, we have to divide it by 4, why?
Because for the sample stand deviations, we always have to take away 1. Yeah, so instead of we divide it by whole number, so all we have to take away 1. So we have 5 data set. We're pretty much doing the same thing, but we need to take away 1 when you divide it by that. But however, when it comes to the population stand deviations, it's cool. It just so this is 6, this is 6, but if this is 5, this is 4. Okay, so we gotta be careful. And then the answer for that we got would be 9.79. Are we good? You need one more try? Are we good? Anyone who need another example? Are we good? We good, correct?
We're good.
Okay. It's the same thing. You just need to shoot the calculator for the sum of the square, and then make sure that. But the thing you have to get out of the exponents, you divide it, and then you get out your close parentheses, and you divide it, and then that's pretty much what we have to get it done. Okay, so just watch my video one more time. When you have any trouble with this, you can check. Oh no, I solved it. So we got 9.8. Okay, 9.8, which is the questions ask us to route to the one to route the answer to 2 decimal places. So I route up to 9.8. Okay, are we good? So now we're going to go for the notations. Okay, so there's a certain notation. So population stand deviation, let me just put it out right there, just like a little box here. And then we can have what it is. So the population stand deviation, we use a letter, we use this one. Okay, we use this. Okay, it doesn't look like what I'm looking for, right? My drawing skill is getting worse and worse. And then the population mean, which is population average. So we're using yeah, we can use calculators. Yes, we can definitely gonna do it. Before that, I always use this formulas. I always use this formulas to compute it and make a chart. Okay, make a chart. And sometimes we just put down the if you read my summary on the Blackboard, I just like do one calculations on a calculator, which is perfect. But anyhow, we also have the sample standard deviation. The sample standard deviation we call S. Okay, very important that we have to keep in mind. And then the sample mean we call X bar. So this is the thing that we have to be careful. So they mean the same. Population mean and sample mean, they basically add them up a data set divided by number of data, but they will be written down differently. Okay, they use different syntax for it. So the population always go with the parameters. It's always a little different compared to what we got from the sample. Okay, it's the same thing for the population standard deviation. They use sigma, but a sample standard deviation we just use S. So now how can we read the questions correctly? Apparently the population, we use this syntax, sample mean we use this, and sample variance we use that one, sample variance. So the variance is the population squared. Okay, so we just take the S squared and we call it sample variance. So we can check, I can solve for it, and it should be the correct answers. Okay, are we good? It's just a certain syntax you have to play around with. Okay, so next thing that we need to do is that we need to approximate it. I'm gonna do this last because this question is tough. Okay, this question is tough. I'm gonna do the last part of it. Okay, Just bear with me. I'm going to come back to this question. So find a find number summary in the quartile range. So we're going to give a set of list of this, and then you want you to look for the minimum, the maximum in the quartile range of the data set. So let me just do these questions here. Okay, so the final summary, again, I'm going to divide the data set into, so we're going to arrange it. So the ages are ordered from the list to the previous. That is good. So we don't have to organize this one more time. So now I want to look for what is the smallest. The smallest will be 29, correct? The largest will be 57. And can someone help me look for Q2? What is a Q2 in this case?
First, find the median in this column. And then for the median, we're gonna look for the first Q1 in the front. And then I think, I'm not so sure, like for the Q2, we're gonna look at the back after the median.
Right. So the first thing you have, so you have to find a median first before we can look for Q1. So apparently that we have 12 data sets. So basically the median is going to be on a 6 and a 7, correct? The 6 and 7 is going to be the Q2.
85 by.
Yes. So if we have two middle number, again, that we're going to divide it by 2. So we're going to add up 41 and 44, and then we divide it by 2. Are we good? So yes, so we're gonna take 41 plus 44, and then we divide it by 2, assuming that we know what it is. So 41 plus 44 over 2. Okay, and then we got that part.
Professor, actually, it's only for the median. I'm sorry, the 41. First, find like the for the median for this point. Say we have the 41 and 44, and then what I did was like I cut it off in the middle. And then I look for the and start counting like 29, 33 out, and then 38, 41. So it's going to be like 35 for Q1. For
Okay.
Yeah, and then for the Q2, is that like Q2 is like a median?
No. So let me finish this question.
Okay.
Yeah. So so first we're gonna just add them up. 41 plus 42. I have a calculator right there. Correct. We have calculators. Where's the calculators? Oh, you don't see it. Oh, we don't have a calculator, so we have to do everything on a paper. So apparently that so 41 plus 44 is 95 over 2 will be 40. I'm sorry, 85 over 2, 42.5. Are we good? So if we have this, and after that, I'm gonna use a line. So we're gonna separate them, right? You're going to separate that. So if we have two middle numbers, you're going to take one for Q1 and one for Q3. Remember that. So let me just repeat that again. If we have one middle number, what we have to do, you're going to cost them out. You're going to cost this out completely, right? If you have one middle number, you're going to cost them out completely. If we have two middle number, then we have to, you can't get rid of it, okay? You have to take one for Q1 and one for Q3, okay? So what that means is that we need to look for Q1 out of these 6 numbers. Okay, and then after that, we look for Q3 out of these 6 numbers. Are we good? So what is the Q1s here? So Q1 will be 35 plus 35 over 2, right? Because we have 6 number, you're gonna pick 2 number, 2 middle number, and add them up and divide it by 2. So we got 35 as well. Are we good? Let me use this marker. Okay, so we're gonna take 35 plus 35 over 2. I mean, it's the middle number between 35 and 35 should be 35, but for Q3 will be slightly different. That's gonna be 48 plus 52 because we have two middle number between 44 up to 57, so that were 48 and 52. We add them up and divide it by 2, and the answers for that should be 50. Okay. All right. Yes. So make sure that if we have two middle number for Q2, remember, if we have two middle number, let me just put a little note here. If we have two middle numbers for Q2, what should we do? We're going to take one to go for Q1, so take one to go for Q1, and take one to, and take another one to go for Q3. Is that good? Okay, so and that's pretty much what we have for the finding answers. Let me just use the solver to get it done. So I believe the thing was just pretty obvious, right? So the interquartile range is just taking Q3 minus Q1. So I forgot to do this math. So 50 minus 35 will be 15. So apparently that this is what we have shown on the notes, and we can definitely gonna check it out. Okay, are we good? You need to try another one, and we good to go.
Professor, like, you know, where you put Q2, just put parentheses medium, because they keep labeling as medium, so you get confused.
Which one?
Like Q2, put medium, like
Okay.
parentheses medium, because that's what it is. You're looking for the.
Okay. So can I just put, I have run out of space, can I just put down that this is the median? Okay, so, and Q1, we call it the first quartile as well. So there's another word for that. Okay, first quartile, or 25 quartile, and then the 25 centile. Okay, and then the Q3, we also take note of that. It's third quartiles. And then this is 75 percentile. Okay. Just want to make sure that people actually get it done. Okay. Yes. Okay, so we need one more. So let me just try another and see what it is. We have 12. Why always 12? I don't like 12. 12 is like too much. So we're gonna take the I'm not so the minimum is 46, and then the lower quartile is, I'm sorry, the maximum is 79, correct? So all we have to look for the median first. The median is gonna be Q2. Okay, so median is Q2. So the question says the Q1 is the lower quartile as well. So the median is gonna be
55.
65, because you're gonna take, we have 6 and 7, right? Because we have 12 data set, the middle numbers should be 6 and 7 data points. So 65 plus 65 for 2 is 65. And after that, I'm gonna separate them and take one for Q2. So this one should be 54, and takes one for Q3. So you have 6 of them. So there's 68 plus 77 over 2. 68 plus 77 over 2, what do we get? Okay, so 68. So we have 72.5. Are we good?
Yep.
So the interquartile range, we just take the upper quartile, subtract the lower quartile. So 72.5 minus 54. And then I got 18.5. Okay. Are we good with that, people? Yeah, that's it. So it should be good. All right. So am I going too fast, or do I have to go in detail? How am I going to get those answers? Okay. All right. So remember, I have to go every single topic for you guys. So I have to cover at least 20 topics for each objective. It's a lot. So I can't really just stay there forever for one question. So if you have concerns, please go back to my chapter summaries and the videos and watch them. So I apologize for that. So I need to move on to the next questions. Are we good? Are we good with that? Okay.
Yep.
All right. So yeah, the quartile range 5. Okay, the same thing for this questions. We have 11. Let's do it one more times. We're gonna have a lot of opportunity to do the IQR. So with IQR is so focused, right? So we're definitely gonna see this question on test, and then we're definitely gonna go over number and see what it is. Okay, so we have 11. I love number 11. It's easy. So what is the middle data set points here? Anyone please help? What is the Q2? What is the median?
$600.
Okay, so that's a good try. Let me check. So it's
Eight
11.
one.
11 should be 6, correct? So that should be this guy.
Yeah, sorry, 601. I messed
Okay,
up.
so that would be the Q2. So just make sure that people don't get it wrong. So it's Q2 we call median. Okay, so if Q2 is one of the data set point, what should we do? Do we go into cut this out, correct? We're gonna get rid of it, correct? And then we look for Q1. So what is the middle numbers for Q1s?
597.
Very good. If we have two middle number, one go for Q1, one go for Q3. But if we only have one middle numbers, so the Q1 that we got here is 597. And what is the Q3?
606.
606. Okay, so Q3 gonna be 606. So what is the IQR? Will be Q3 minus Q1. So that would be the middle half, okay? So that would be the difference between Q3 and Q1. So we take 606 minus 597. So in this case, that should be 9. Are we good? So we can fill up the box relatively easy, but I'm not gonna do it. I'm gonna let the calculator help me do that. Okay, so we have calculators here as well. So then we go into calculate the lower fence or the lower boundary, whatever the term you want to call them. So the lower boundary in this case, a lower fence, or the book that use boundary. And then what we have to do, we're gonna take Q1s, which is minus 1.5 times IQR. Let's give you the form for that. Remember when you read the questions, it's give you the form, it's right here. Okay, so we take 1.5 multiplied by the IQR. And then all we do is just like Q1 with 597 minus 1.5 times 9. What do we get here? Okay, so I need help. All right. So we got the answer. We're 583.5 over here. Are we good with that, people? And then the upper fence, or which is called the also called boundaries, upper boundary. So that would be Q3 plus 1.5 times the IQR. So Q3 was 606 plus 1.5 times 9. So we should be able to get it on the calculator. So we got 619.5. Are we good? And then after that, any data set that's not in this range, we call the outliers. So let me just check them. So the answer is 583.5 and then 619.5. Is that good? And then do we have any data set that we call the outliers? No, correct? So we have no outliers because every number is basically in this range. So we just go to answers no. Okay. Are we good? So when we have no outliers, just put down none. Okay, so just click none. Okay, click none. So we get it. Are we good? If we have more than one, you have to click here to get to whatever it is. Is that good? Is that good?
Yes.
Okay, so can I move up to the next question?
You sure?
Okay, so let's go to the next question. So I'm running out of time to finish this since we have another really hard question to deal with. Okay, so each hour, several hours, the owners of bakeries or sometimes we call the mock plot summary data sets. And so let me just summarize the pop plots for you guys and see what it is. And I believe it's really good to know what that is. It's actually, the box is really big. I can make it smaller. So this is what we call Q1. This is Q2. This is Q3. And this is the smallest. And this is the biggest, right? So apparently that we can read all of this on the notes. And so what are the smallest customers? Those smallest customers of 26, correct? What is the median number of customer? The median number of customers should be 42, right? What is the third quartile, Q3? The Q3 should be 48, right? Is that good?
Yes.
Can we move up to the next questions real quick? Okay. Can I move up to the next questions?
Yeah.
Okay,
Yeah.
so let me just repeat that again. The smallest will be
The
right
min.
here. Yeah, the minimums, right? The biggest
Yeah.
should be the longest one is 54. Q3 should be 47, 48. Q2 42, and then Q1 is 37. Okay, so that's pretty much it. Let me just move up to the next one real quick. Okay, so that one you have to do it on your own. Okay, so you have to send your calculator, sort it. I definitely can't help you. Okay, yeah, you have too many numbers, so you have to do it on the notes and figure it out, and then construct a box and plot whisker, whatever it is, right? So we have 19. That's too many data set point. So 19, you have to look at the 10 data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 15 should be Q2, right? Correct. And then the smallest will be 6. And then the biggest should be 30. Okay, so and then so 15 was Q2. It was 10 data set. And then I need to get rid of it. And what is the middle numbers between all of this? So that should be 11. And the same thing for that. And this one should be 22. Okay. Are we good? You have to do it on your own. So we have sort data set and do it. Solve. Get it. You can just go max out whatever and then solve it. It should be right here. Are we good? Okay. Is that good, people? Okay. So now we're gonna move to the next one. You have your sorted your local keyword kitchen. Okay, so now which city has the larger median? Median is what? Median is right here, correct? Which one has a larger median?
CDB.
CDB, correct? So I'm not gonna do it, but I'm gonna help we get the solver do it at the end. So it's CDB. Which city have more noon temperature above 79? Has more.
Also CDB.
Think of it. They do have a same number. Okay, they have the same numbers of the data sets. Okay, so the CDB only tell you that it had the smallest temperatures, which is around 62, right? But it doesn't necessarily mean that. So 25 percentile, this one occupy around 25 data set point. However, the questions ask us about 79. Yeah, CDB should get. I'm sorry, I didn't read this question. I thought it asked me about 70. So yes, 79 it should be CDB as well because it's going to occupy more data set point around this corner. Whereas when you look at CDA, that for 79 only have 1 or 2 data sets. They only occupy around like 25 last percentile. So this one actually occupy less temperatures. above 79 Fahrenheit. Okay, so I apologize for that. I didn't read the question 70. I thought it was about 70. If the question changes 70, so that would be CDA gonna get more moon temperatures above 70 degree, but the 79, of course, CDB gonna be the thing. So which city had the highest moon temperatures?
And it will be City A.
CDA, so that should be around 87. So apparently that. So which one had the larger IQR? IQR going to be Q3 and Q3 minus Q1. So we look at CDA, we take 77 minus 71s, right? 77 minus 76. And for CDB, you take 83 minus 76. So CDB should be should have a higher, correct? Should have a higher IQR as well. So we can read them and answer these questions apparently. Oh, they have a same IQR. So let me maybe they just do the math wrong. So we can try it. So 83 minus 76. Would that be the same as 77 minus 71? So if they have the same thing, so they have the same IQR. Are we good?
You can also tell by the shape of the box. I
No,
mean, I don't
you
know. That's just
sometime-
like,
yeah, we have 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6, 7. And this one, 1, 2, 3, 4, 5, 6. Yeah, they have 7 more. They have the same more. So they have the same IQR. Yeah, should be. Yeah, if you see that 2 box that have the same length. From Q1 and Q3, they must have the same IQR. You want to try another example? We could.
I'm okay.
Okay, let's try another one. Then we'll move up to the next question. Which one has a larger IQR? Apparently city A, correct? So because Q1 and Q3 right there, correct? And which city has the highest mean temperatures? Please help quickly. Which one? B. Okay, which city has more noon temperatures above 81 degree?
Shouldn't it be?
both?
Yes, that's a good above 81, so that should be both because they occupy the same Q3, so that should be both, correct? They occupy the same Q3 right there. 81 degrees for both of them. They both have the same 81 degree for Q3. So the last 25 percentile should be the same. So they must have the same number of the noon temperatures above 81 degrees. Which one has a larger median?
B.
Large B, yeah. Apparently the Q2 is right there. For CWB was Q2 was 76, for Q1 was 73. So are we good?
Wait, I have a question. So
Yes.
they both had the same number, but isn't the end aren't the whiskers part like the minimum?
It's not about. So are you talking about the part C questions right here?
Yeah.
Okay, let me just explain to you why they have the same thing. Okay. Let me just copy this one real quick. Okay, and let me just copy it. Okay. Oh my goodness, I don't have space. So can I just? I'm trying to save some slides so that you don't have to. Maybe I just make it smaller. Okay. All right. It looks terrible. Anyway, so okay, so the reason why they have the same number above 81. So we look at 81 degree right here, correct? So when we look at 81 degree, oh, why is that happening? When we look at 81 degrees, so they have the same Q3, correct? So the Q3 for CDA was 81s and the Q3 for CDB also 81. So what that means is that start from 81, the last 25 percentile must have the same data set points, the same number of data set points, correct? So let's say we have 20, so meaning that around 15 data sets. I'm sorry, if you have 20, around 25, so 20 over 4. So if you have 20 data set, meaning that the last 5 data should have more than 81 degrees, correct? So they both have the same numbers. Does it make sense?
Oh, so in order to get 81
Yeah.
third quadrille, you have to have the same amount of data set numbers.
Yeah. So the same thing. So that if because both CDA and CDB recorded the same number of data set points, correct? So they both have like, let's say 100 data set points. Okay. So they have the same Q3. So starting from Q3 to the rest of the data set points will be around 25, right? So we have 100 data, so we have a 25 data set. So there, CDA has 25 data set, both 81 Fahrenheit, and CDB also had 25 data set, both 81 Fahrenheit. Okay,
Yes.
the same data set, same number of data set point. Data sets, starting from 81. Because they occupy the same Q3. They occupy the same Q3, which is occupying 25% of data set point. Okay. Are we good? Okay, so is that clear? Or okay, so yeah, and then we're gonna move up to the next questions. I think I don't have time for it. So I'm gonna come back to the hardest questions in this case. So this question gonna be on a test as well. The hardest part is like we need to approximate the standard deviation of data given by histograms. So we have to go over this question. Approximate the standard deviations of a histogram. Okay, so this one is relatively, it's actually critically hard. And so the formula for that, of course, we do have formulas here. And the formulas, I would say, just that one. This is relatively hard for some reason. It's just, no, they didn't give me the picture. Shame on them. I really need the picture for that. Okay, so let me try another one. So, frequency. Right here. And okay, so let me just try and see what it is. No, I can't really go to the chapters right there. Okay, so this one's gonna be the thing. All right, and okay, so let's try to do this question. So a sample, so there's a sample, correct? And then the graph are gonna give us the points, there's the chart, so we're gonna look for it. Okay. Okay, so the first thing that we need to do on the test, okay, on the test, you need to figure out what is the middle point. What is the middle point between 0 and 4?
2.
2, very good. And what is the middle point between 4 and 8?
6.
And 8 and 12?
10.
Right, and then so on and so forth, right? And then so we can figure out a middle point is relatively quickly. So we have 6, we have 10, we have 12, 14, and we have 18 right there. Okay, are we good? So we're gonna take the middle point and then you're gonna evaluate it. And then first thing that we need to do is that so the frequency will 10, 15, 20, 10, and 5. Okay, so in order to do these questions, first, you're going to figure out the X bar. So the X bar is called the means, the estimated mean, the estimated average. So we're going to we can use calculator. The calculator doesn't really have this function to help us compute what it is. I'm trying to look for the computational formulas if that works, but it's not actually true for every single case, so we can't really use it that way. Okay, so we can't use a calculator to get it done, so we have to do it by hand. When it comes to by hand, it's always be hard. So first we need to look for the X bar. Wait, hold on. I think they have another formula. So they do have the computational formula for this, but I'm not sure if the Alex has it. Okay, so so what I have to do, they do have a computational formulas for it. Of a frequency. Let me just try it and see if they have it. I feel like this is only I can't write them down, but I'm not sure. Maybe I can read it. Yeah, that one is good. That one is pretty good. Yeah, maybe I use this one. Yeah, I feel like that's good. No, we have to divide it by n-1 actually. It looks complicated that way. So first thing that we need to do, you need to find a midpoint. And once you consult a certain formulas that we have a list of formulas. Yeah, I feel like that would be the one. So we're gonna take the midpoint, subtract the X bar. So are you stuck on? Yeah, I'm trying to use a calculator, but it doesn't work that way. I can use SL, it's easier, but I don't think that you're allowed to use SL. So 2 times 10 plus 6 times 15 plus 10 times 20 plus 14 times 10 plus 18 times 5. Okay. And then we divide it by the sum. So the sum that we have would be the total frequency. So we have 60, right? So 60 frequencies from the question. 60 frequency. Yeah. So we divide it by 60. And then we just, yeah. I'm sorry.
Dion 6 months ago, but I think we can overlook that. He's smart.
Okay. If you're watching a movie, make sure that you're gonna mute your microphone. But we gotta mute it. So and make sure that you're gonna tell me which movie you're watching, so I can take a look at it. So we can take 2 times 10 plus plus what? Let me just go back there, back to the question. Plus 6 times 15. So we have to do all of this math. Okay, 6 times 15 plus plus 10 times 20 plus 14 times 10 and 18 times 5. So the answer for that is 540. Are we good? So we're gonna get 540 in these questions over 60. Because we have 60 data set point, so 540 over 60. So the answer for that should be 9. Are we good? Are we good with that? So then we're gonna look for the standard deviations. So the standard deviations that we have according to what we got here. Okay. We take the square root, so we can't really do it on calculator, which is a sad fact, because the reason behind them, because after we take the thing, so we're gonna look for, like, gonna take the midpoints to minus the X bar, which is 9, time, we're gonna square them, we're gonna square this part and multiply by this frequency. The frequency that we have is 10. We do the same thing for 6 minus 9, we square it, and then we multiply with the frequency will be 15, because there are 15 data set that fall between 4 and 8. So we have to multiply with 15 Same thing, we're gonna do every single one. So we're gonna take 18 minus, we're gonna take the midpoint. So the midpoint, those are midpoint, take 18 minus 9. The 9 gonna be the average that we got here, square, and then multiply it by 5 here. Okay, so let me change the mark a little bit so that I can see things a little easier. So this one, you're gonna use this, and then when I just subtract them, so the point that we got over, so subtract 5. So we can easily see what it is, right? So we can know that this is just the average that we can just compute it previously. And then we're gonna subtract 9 here, subtract 9 here. Now we good? So then we can do all of this on a calculator, and then we divide it by 59 instead of 60. So 60 minus 1. Is that good? Is that good? Do you want me to do that? You want me to do them? So it cannot be done on calculators faster. So we have to take, so 2 minus 9 will be -7 squared. So it'll be 49 times 10 plus let me just go back to the notes here. So 6 minus 9 is -3. Square with 9, 9 times 15. Plus, let's go back here. And then we have 10 minus 9 is 1. 1 square is 1. 1 times 20, just 20 by itself, okay? So we have 20 frequency for that, so we'll multiply by 20 plus, and then 14 minus 9 is 5, 5 squared, 25, 25 times 10, 250, okay? Plus, and then what we have here, we have to take 19 minus 9, 9. 9 squared going to be 81, 81 times 5. Okay, so we're gonna got this one. The total on top numerators is 1300. Okay. So the S will be equal to the square root of 1300 over 59. All right, is that good? So 1300 square of 1300 over 59. Over 59. So we should be able to get 4.694. Okay, 4.694, which is just 4.7. Are we good? 4.7. Is that good, people? How many of you understand what I'm doing here? How many of you understand this?
Could you do it again? 'Cause
The
I don't know where you get 2 minus 9 from.
2 minus, so 2
Well,
gonna
no,
be
the
the
9 especially.
yeah, 2 gonna be the midpoint. So all of these are the midpoint. We call the midpoint of the frequency. So when you see the formula list, it's gonna be called the MI. MI, and the midpoint. And then so we're gonna take, so first we're gonna take the midpoint, multiply with the corresponding probability, with corresponding frequencies, and we add them up. Okay, we add them up. Okay, and then we're gonna got the answer, which is X bar equal to 9. Is that good? So,
Oh, okay, I see what you do.
yeah. So I'm planning out use different markers and to get it done. So now we're gonna take each midpoint. We're gonna take each midpoint. So we just change that to MI. So just want to make sure that we understand what it is. So this is M. Okay, we take the midpoint. We subtract the average. We subtract the mean. So we subtract 2 minus 9 squared, and then you multiply with the corresponding frequencies. The frequency was 10. The same thing, we take 6 minus 9 squared times 15, 10 minus 9 squared times 20, 14 minus 9 squared times 10, 18 minus 9 squared times 5. Okay, and then we divide it by 16 minus 1.
One more question. On
Yeah.
the formula, it said F. What does that mean?
The F means frequency.
Oh, okay. Okay.
Yeah, frequency. Yeah, so that's a good question. The frequencies should be on top of that, right? So all of these numbers are frequency. It's right here. Is that good?
Yeah, I'm good.
Okay. So now, anyone who needs more help with this question?
I mean, I feel like this one is easier than the one we got. We got
No,
like
this
high
one,
numbers.
this one is really complicated. This is what it told us. Like we have to first, we're gonna look for the X bar, which is 9. And then after that, I'm gonna plug that in. So I can copy this one down if we want it. Okay.
Yeah, mine's is like my histogram has like bigger numbers for like between 700 and 750, and it's bigger numbers to
I see.
to calculate.
You can try another one to see what it is. And yeah, that one is like so many decimal point, just something that I do not like, but it's you're gonna use the same format to compute it. And there's nothing actually different. The same thing that we're gonna go for, like we're gonna take the X bar, we're gonna take each the midpoints times the corresponding frequencies, add them up. Each midpoint times the corresponding frequencies, add them up. And then got 3.5, and then we do the same. Okay. All right. So I know this one is really tough. It's just take your time to get it done. Make sure that we have to subtract the average. I mean, we do have a computational formula, but it's just sometimes it's harder. Okay, so I believe it's so far so good for this chapter summary. I believe it's wonderful everything. And then we're gonna move up to the test review. Okay, so how many of you want to do the project today? Or if we want to go for the test review, or maybe we can spend 1 hour going over the test review next Saturday, and then after that, and then the rest of the time today we're gonna do the project. Which one you want? I believe like going over.
I think I would like to go, I mean, next Saturday, do data day first and then do the review.
No, we don't have time to do both of them. Remember, the test started at 10, so we can't really do it.
The
We
test
can't.
is next week?
Do the data bit.
We're gonna do the data first, right? So then the next week, we're gonna do the test review question. It's 10 questions right here. I post solution right there. You can check it out. I mean, it's pretty much,
So we take the test next week as well.
yeah.
So we're gonna do a review before class and then the
Yeah,
test.
and the test, okay? But I really want people to just go over these 20 questions first. Okay, go over it. If you can't really figure it out what to do, then you can ask me questions you can ask me questions next Saturday before we take the test. Is that good? Is that good, people?
Yes.
Sure. I can email you if I look at it over the weekend. And
I post solution, but I post solution for each question. So what you
Okay.
can do, what you can do, this is the solutions, okay? Yeah, I post solutions, so you don't have to email me about the answers, but if you can email me which solution that you don't understand, and I will be going over it. Okay.
Professor, why you put it in Blackboard?
on Blackboard, under exam review, under the project assessment, there's a little folder right there. So it's called exam review, so we can go over it.
Okay.
All right, so the project is gonna be on a data date, right? So this is what we have for the whole project. So we're gonna do the project now, but because we need to have access to SL. If you don't have SL, I have a couple of students on Tuesday and Friday class telling me that they do not have access to SL. So if you don't have it, let me know, okay? So the Hunter webpage, they get it for free, okay?
Access to what?
They don't have the SL, they don't have the Word, the Microsoft Office.
Oh,
Yeah, so it's happening that people don't want to pay for it, of course, including myself. This is pretty much the old SL file, but we don't need them. We don't need them. So first step that what you do, you're gonna go to Start, and then you're gonna save it. Okay, you're gonna save under. I don't have access to it. I don't have access to that. So just email me, and then I'm gonna send you the link so you can get it for free. It's coming from the CUNY. You can go to the CUNY programs, CUNY software, and Microsoft Office. You can download it for free if you're a student at Hunter College. Okay, if you're a student at Hunter, of course you are, and then you can download it. So now, first I need to save the data set. Okay, I need to save the data set under CSV. Everybody see that? So let me repeat that again. So first we need to save the data under CSV. It's not CVS, I'm sorry about that. And then CSV, and then it should be in terms of comma delimited. Okay, is that good? Is that good, people? Everybody save that? I'm not sure if you can watch me video one more time. So, comma delimited. Okay. Are we good with this? And then you're gonna pull out your JASC. You pull out your JASC. It's gonna take a while. Everybody sees that? So pull out your JASC, and then pull down. Are we good? And then you're gonna click open. And on top of that, you're gonna see a little bars like this, right? I'm gonna click open. Go to the recent file computer. Okay. So let me just copy that part, and then you know exactly what to do. Are we good? Is that good, people? Is that clear to us?
Okay, so Professor, we are supposed to copy the survey to JABS.
Yes, so you're gonna, the only thing that the JABS work is only work for a CSV in terms of CSV or text or JASC, but it's not working for XL, XS, whatever it is for the SL. So we have to save it under CSV or text. That's perfectly okay. So we have to see the order of this format. Click open. Yeah, so if you're unable to open it, that's the problem. So you're gonna watch my video one more times and do it on your own. Okay, we have 2 weeks to get it done. But once the first project, the deadline should be slower. Okay, so it should be like 2 weeks for the next project because we're all familiar with them. We're gonna do it fast. Okay, so remember that we should be able to open it in SL file. If you don't have it, just send me an email. I'm gonna shoot you to the Hunter software list, I mean, the CUNY software list. So I think that you should be able to download it for free. Okay, so that's the part. It's Microsoft Office is free. Or if you're unable to do it, you can borrow your. I think I'm not sure if the people actually. I actually use another disk that has a free Microsoft Office, but it's not illegal actually. So right. So what I'm asking people is that if you don't have it, if you don't have the Excel, you can't open it, then just email me, and then I want to ship you to the Hunter. It's just you can't go it. The Key Microsoft Office, right? And then right. I think we can get it relatively easy for that. For a student, this is for my education. We can click, and then yeah.
Professor, actually, I have Excel on both of my desktop and then my laptop. The only thing is that I don't have like the CSV one, and
No. It's the CFE, and you have to save. You have to save as CSV. Yeah, you have to save. You have to save first. So this is what I put it first right there. So save the data under the CSV.
Okay.
Okay, save it under CSV. So that's the big part of it. Okay.
We'll try that again. Thank you.
You're welcome. You're welcome. So then pull out this JASC and then click open. Right, click open, and then go to computer sections, and then you just click the student data 19. Open, then computer, then click then use the browsers, desktops, whatever it is. And then install student data 19. Is that good? Is that good, people? On my computer, open it to get the screen that request product. Yeah, you can. Unless you have to pay for it, that is not worth it. So the CUNY, they offer some free SL files. Okay. Yeah, you can get the free use for that. And right. Because nobody going to pay like more than $100 for a data date. So I really want people to be able to get it from the Hunter email. So you should be able to use for free. Okay. So if James can help us get to that part, it's great. But remember, I can't really wait for you guys to download a package and then keep pacing that. So I have to keep going. Okay, so now the next thing that we're gonna go to the script statistics. Okay, so next we're gonna go to script statistics. Okay, so that's gonna be the things that we have to do next is separating point. So we're gonna click on the script statistics, you're gonna see a certain thing like that, okay? Is that good? You're gonna see a certain thing like that. I'm just gonna copy and paste right there. Oh, I always don't have enough space for this anyway, so. All right, so just take that part. Okay. Is that good? Everybody get to that part? Is that good, people? Is that good, everyone?
Yeah. Uh-huh.
Okay, so if we get up to that part, then we're gonna go for, we definitely have to go for the, so we're gonna describe a certain variable filters on the Word file. So we're gonna go for Word file. Actually, it's 2007 for the second. So we're gonna, this is the project, data day once, right? Data day once, and then on top of that, we're gonna go for to college. And then this one's for 2022. This is your names, right? And then you're gonna put down your name here. And what else? And this is the stat. 113s, statistics. Okay, and so on and so forth. Put down your names. And this is the data they want, and that's pretty much what we have to get it done here. Are we good? So then after that, we're gonna go for the names. Okay, so let's say you're gonna put that in names. It should be about 12 and 14. That's fine. So the name of variables. So first, we're gonna put for ones. What is the first variable I can see? So that would be the years here, right? So what is this? So that is what? The year is going to be, anyone knows? What kind of variable is this? People? So years will be the nominal data, right? Measurements. Correct?
Correct.
Okay, so this is a categorical data set. Right? Correct? Is that good, Pete?
Yes.
Okay. So we're gonna say some space for that too. And then and then that's pretty much it. So the years also it's continuous or discrete. It should be discrete data sets, right? So you're gonna name all of them. And the second thing that we're gonna do will be gendered. Gender will be also categorical data. And then this is also nominal data set measurement. Okay, and so on and so forth. And 3 and whatever. Okay. And 4 and 5 and 6 and 7 and 8. So we have total 8 of them, right? No. We have 13 actually, right? And we have 13, okay? Is that good? So now using the arrows, so we're gonna go this one, the little bar right there. This one, a little bars here. When we have a little bars here, let's say we have a little bar for this part. It's just like so this is like a quantitative data set or numericals, right? Numerical data set. Yeah, it's the same 13th variable for everyone. So so this, let me just copy this. Go for it, right? So all of this is numerical. Correct, and then the categorical patterns should be around this one, right? Categorical should be this. Right? So the years and gender we call nominal data. Okay. And then we also have piecing. So the piecing would be called a sibling, birth order, whatever it is, we call ordinal data set. Okay. Okay. Okay, are we good? So you're gonna let me know on Word files. So the first thing that we need to do is that on JAS, we're gonna just put down all the numerical data sets on the other side. Okay. Everybody see that? So the results should be on this side, okay? The result should be on this side. Everybody sees that? So you can copy this, and then you're gonna copy to the Word file. Is that good? Are we good with this? After we name all of those, but we just copy the script statistics from the from the chart. But you might not use this chart, so we can modify all of this under statistics, right? So if you want to name the quantiles, you're gonna see some quantiles here, right? If you want to look for skewness, you can see the skewness, but we haven't learned what it is, so it's fine, right? And then, so this is what we have to copy them. So this is where we're gonna adjust the descriptive statistic charts. Is that good, people? So just copy that down and post this here. Oops. Are we good? Is that good?
Professor, are you going to be posting this video so I can refer back to it if I get lost?
You can look the videos on the. Sorry. Yeah. Okay. Yeah, it's right here. The lecture video should always post it on Blackboard. Okay, the lecture videos can be found under lectures under lecture notes, right? So we're after it. So all the videos will always be here, and you can definitely watch them again. How to get it done. Okay. Now I'm gonna get back there, so I don't need to just get rid of it. Okay, is that good? So we're gonna try one more times. Okay, so now the thing is that we need to pick two of them. Okay, we need to pick two categorical data. That's your choice. You're not going to do all of them. Okay, pick two of them. Okay. Okay, sure. And then you're going to pick another two numerical data sets. Are we good? Is that good, people? So we have to pick on your own. You can't really tell me that, well, I picked the same number of data with my friends, so it should be two different things, right? So you can pick any of them. Okay, I can pick. So let's say I want to compare the siblings with the piecing, for instance. So I can pick those two. Okay, I can pick the gender and the piecing for that. Are we good? You can see the chart. This was statistic, not spelling point. Okay, so in other words, that we're not going to do not doing descriptive statistics or categorical data for this, right? Okay, so what we need to do will be on the bottom. So you're gonna see some basic plots right there. Everybody sees that. So we're gonna click to the basic plot. There's actually a lot of them. So if you want to go for the scatter plot is not working out. Scatter plot, you don't see them because there's no way you can get a scatter plot. No way they can get plot plots for it. Because I think we can for piecing, but only for piecing. It's not very important for that part. Okay, so the things I really want you guys to focus on will be pie chart. Everybody see the pie charts here? Are we good? Dot plots. Okay. It is not so important for, let's say, go for distribution plot and see what's going on. It's easier. So click pie, and the QQ plot it doesn't work for some reason. The QQ plot just doesn't mean anything because all of them is going to be the same. So we're not going to use the QQ plot for that reason. Okay, so we get rid of it. All right, so all we need to do for those things that we need to do two types. So the first distribution plot and then the pie charts. Are we good? So we can copy that down. Copy. Okay, and then I'm gonna go to the notes. So I am taking two categorical data set, which is, so this is my pick, so you should have different things, so piecing and gender. And genders, okay. And then after that, I'm going to get this. Okay. All right, so it doesn't seem to be really good for me. I'm going to remove it. I'm going to copy one by one. It seems a little bit too big. Okay. Maybe we can say image. No, can section add an image. No. Okay. So just copy that and then go to the file. Make it small, make it smaller. You can go down and then, all right, is that good, people? And then, so this is one image for piecing. And then versus genders. Oops. You can make it a little smaller. All right, and then also we're gonna have to copy the gender charts. So again, we're gonna copy this, make it super small. Okay. I think that not working. Okay, let me just try it this way. Is that good, people? Okay, so, and then we can also try, and then we have to copy those two and post this, right? How can you copy them? You can see an arrow on the bottom. So you're gonna copy that. And then, so what can you say, what can you say about the female and male, right? What can you say about the piecing, so we have 60, around 60 count, 60 people, or 60 people doesn't have piecing. We have 9, well, we have one person have 9 piecing, whatever it is. So I don't, you know, explain it. You have to explain it, right? You have to explain to get credit for it. I'm trying to make this as small as possible. All right, it's still too big for that. It's just stuff like that. Okay. It's due next October 1st. October 1st. Okay, October 1st. Yeah. And then the same thing for you're gonna copy yourself, right? The same thing for gender. So we're gonna go for copy. And then for gender, I'm gonna go for this. You have to explain it what happens, and gender is more. The gender is more. The gender is so it's more male based. The female is only occupy 40%. Male is 60%. So you can also write it out that way. Are we good with this, people? Is that good? And then pick, so we found out you have to make a conclusion for that. You have to say, well, I found that my chart is not symmetrical. The piecing is not symmetrical. The piecing, why is that? Because there are actually more people who are not having this. And then there's very likely that we have people who have 2 piecing, the second most type of frequency, and then you know, and then the rest of the majority of them doesn't have piecing for that reason. So we can explain it, right? Explain it, right? Explain the graph on both bar charts and pie chart. Yeah, sorry, I posted black. But I'm not gonna like. I'm not gonna just do it. You have to pick your own, right? You can't just copy my work saying I also pick piecing and gender, so that's choice. So now we're gonna go back there. So it disappear right away if you bring back up. So you can see that it's gonna create it right away. Correct. So if you bring back down, you're gonna move forward. You're gonna get rid of it completely. Okay. So this is all we need to set up for your basic plot. If you move up, move down, move in, move out, and then you're gonna get the thing set up relatively quickly. Yeah. Oh sure, Shallow, I got you. All right. Are we good with this? So we can also compare the GPAs and SAT. I believe that's make more sense. So, and then the next, I think the next part, you have to do something. You can't just like, well, you might want to make it look nice for the next part of the chapters. Next, we want to pick 2, the next, I am going to pick 2 numerical data sets. Which are GPAs or something like this. No, I said GPAs and SAT because I believe people who score well on SAT do not mean they have good GPA. I think it doesn't make sense, but anyhow. You have to actually explain it, right? Yes, cleaner. Just you have to let me know in the chat, so I can't just basically mark you present. Okay. Okay, so and now what we need to see right here. So it just automatically tell me that. What do you think about the GPA? What do you think about the SAT, right? So we're gonna copy that as well. So first, I look for the statistics. The statistics already done. Description statistics already done, it's right there. So for the mean for SAT with 12, 35.8, the standard deviation is 120, and then GPA for the mean was 3.2, the standard deviation is 0.357, the minimum for that. So we have those two, so you don't necessarily have to give me that statistics, okay? With data, sure, just let me know, just tell me a time that you want to come, so we have people might want to join as well. So give me your fixed times on Friday. Start from 3 p.m. until 5 p.m. So you can definitely go. And I feel it's pretty straightforward, right? If you get lost on the data, it's just a few clicks. All we need to do is just click them. Yeah, and then after that, we'll just click the same thing. So you might want to look for correlation plot. You don't have to, because if you go for scatter plot, show you what it is. So those two are basically the same thing. Okay, so you want to go to plot right there, and then the scatter plot. Okay, make sure that you hit none for all of this, and then you want to show the linear. Okay, is that good? Is that good, people? And that's it. Are we good with this? You might want to look for that plot, just want to see if they.
Professor,
have-
it means that we have to do like four.
I'm sorry?
graphs. We have to do 4.
It depends on the things, but generally, yes. So let me just put it down here. So we need to do the pie charts and bar charts, right? It's just a 2-click or categorical. Explain why you picked this. Okay, so, and then after that, we have to do statistics. Statistics, this is that what we have to get it done on the first part of it. So you might want, you have to do the bar charts, you have to do the box plot, right? Okay, and then you have to do this correlation, the scatter plot, okay? Which is a correlation as well, it's basically the same. And then we have to do the dot plot right here. So it's a total would be 8 plot that you have to consider. Is that good? And then it's just right there. You just click them, right? Scatter plot, none for this part. Bar plots, you want to go for bar plot elements on a yes. And then yes, right here you can go with violence element that is gonna change the shape, but please do not do it. Okay, you can do some label outliers. Maybe that's gonna work. It's gonna take time to fix the model. It takes time for that. Okay, and then you're gonna label the outliers. Do we have the outliers here? Yes, we do have the outliers, so you can label them, right? Is that good? Any questions? We don't need the correlation plot. Actually, correlation is unnecessary. It's just a summary of what we have done right there. So we just take 6 plots here. Okay, copy that, and then go for GPA plot. Okay. Is that good? And then we're gonna go for, SAT. The same thing.
Professor, we have to do 5 in total, is that correct?
You have to do 4 data set total.
Okay. So the 4 data set it should be like
We have to do like 2 quantitative, 2 categorical and 2 numericals.
And then in the category, we could pick whatever the category part
Exactly.
and then
Yeah.
do the pie chart and follow
Yeah.
the instruction.
Mhm.
And then
Yes.
copy paste in the list. And the same thing for the numeral, like GPA, their age or stuff like that. And
Yeah.
then do that with the, like, according to the note.
Yes,
Oh,
but you
that's-
can't, you cannot pick like, birth order and the math SAT, for
Oh,
instance.
definitely.
Yeah,
definitely.
you have to pick like 2 of them to be the same, put it on the chart.
Have to make sense, yeah.
Yeah, so you can pick any of those, right? But you're not gonna do like, you're not gonna do all of them. Just pick 2.
Okay.
Each person gonna pick 2, right? Pick any 2. You cannot pick like, so FERP it's AT and then SAT math is, and then you can do that again for another one. No, you don't have to, just do it one time. So let's say I want to pick the height. I believe that people have I believe tall persons going to have a good SAT. So I want to compare the height and then the SAT. So this is gonna be on the second data day, but we're gonna do it first here. We're gonna see what it is, but we're not gonna explain it that much. Okay, we just simply tell us whether the graph is symmetrical or it's to left. So SAT is more symmetrical than GPA, for instance. So by looking at bar charts, right? So we can explain it. We're gonna have 4. We're gonna have 4 shallow. We're gonna have 4 data set day, 4 data day. So this class, but is that easy to do? It's just like a few click, okay, and then you just get in, and then you get out, right? And then I'm not sure. Oh, I get out. Come on. And then I get out, disappear, right? It disappear right away. Okay. And then you do that one more times. You're gonna show back up. The only thing that matter is you have to click 2 of them. The basic plot, you have to check on distribution plot. Pie chart doesn't make sense. Pie chart cannot work on the numerical data. Even if you click them, it's fine, and then adopt plot, and then for the next one, then we have to put a check on the box plot and then the scatter plot. Okay, and sometimes you want to label the outliers, and then for scatter plot, make sure you check none. For all of this, you want to add the regression line, and it has to be a linear. Now, the project's gonna be due on October 1st, okay?
Data day 1 or which project you're talking about?
The data day ones, yeah.
Okay.
Yes, due October. So the first data day, it cannot be like, I need people to get used to it. I need people to download your Microsoft Word. Office due date will be a little bit behind the other projects because I need more time for people to get used to the project, so to get into JASP and how to get it done. Okay, due date is October 1st. Okay, is that good? Okay, all right. At least we have 2 weeks. Yes, absolutely. The first data day, remember, it's always like 2 weeks long. The second data date, it will be a little bit fast. This will be 1 week. We're gonna have 1 week to finish it, so I can put the grades in and let people know what it is. Okay, is that good, people? Is that good? You want me to copy all of this, and then you just say, "This is my project." Come on. All right, and then okay, so this is like a cost sample project, right? I'm not gonna finish. I'm not finishing all of this chart. You're gonna do it on your own. Okay, so for this one, we need what? Let me just see that one. We need bar charts, right? We need bar charts, and we need scatter plot, right? And then we need bar plot. Okay, box plot and dot plot. Okay. All right. So each one you reach here. Just want to be fair. So if you don't know how to copy the charts here, just let me know, okay? Make sure that you're gonna put all these functions correctly. Yes, so no, we have to identify all of them. So that is the thing. If we want to make a chart, we just simply make the chart according to what you pick for a number of variables. So let's say we pick two categorical data set, we just make a chart for two of them. And if you make a chart for numerical data set, we just do two of them. But when we explain, we have to explain all of the 13 data that we have. Okay, so this is a required. Is that good? Because I think genders, males have more pieces than female. Is that true? And female. So we have to test. You have to whatever it is, right? And then yes, question.
Professor, for jobs, do we have to purchase?
No, it's free.
And one thing I noticed about JAX is if it's like if my desktop is a little bit old, so I try to download it, but when I want to run it or to open the file, it didn't let me. So like the JAX is like depend on the model of the computer that students are using too, I think.
Okay, so if your model is actually pretty old, I would suggest you. I would suggest you should land a laptop from the computer lab and then download JAS. I'm not sure that you can do it on a computer lab because the JAS is not available. I request them. I request from the Hunter College, and I'm trying to get the JAS available to all of us for Stat 113, but it's gonna take time, right? It's gonna take time for people to institute the installations and all of this. So it might take maybe 1 or 2 months to get it done. But yeah, so to make the JAS available on a computer. So what I suggest you that, well, I mean, we can borrow your friend's computer and then try to get it done, download a JAS, and then you finish it, just give him back the laptop, say thank you, appreciate it. So I believe is helpful. Okay, so it just take a few clicks. The reason why I love JAS because when it comes to the graph, just take like a few clicks and you have every single function right there. It's relatively easy. Okay, it's relatively easy to get it done. So so this one is just the thing that we can use it nowadays. And then it's very convenient. Just have a few clicks. You click them, you see the result right away. Okay, so I believe it's pretty much what we have right there. Any other question?
It's only that I try to put the file, save the file as CSV, and I'm still unable to open the file with the JAS.
You have to save it under CSV, comma, delimited.
Because like the one that I have look like the different. Yeah, the one is like green one, not the blue one. And it didn't give me the option. There is only one. It's like something limited. There is only one option for CSV. Yeah,
Okay.
here you have 3.
If you can't do that, you can save it with a Unicode text. I'm not sure if that works. So let me try them, or maybe the text, whatever it is. So let me just try to save it under Unicode text, and I'm not sure if that works. So let me just try them one more time. Is that good, people? I just want to make sure that it's good. The project is good for all of us, and so you can see the explanation, explain what you picture, and then compare them, right? So we have to compare them. We have to compare these two. What happens, right? So compare the charts with certain characteristics. The following characteristics. It should be relatively easy. It shouldn't be that long. So, okay, you want to compare them with the graph. Here's the graph, symmetrics. Or, school left, school right. Or right, and then. And do we have the outlier for this? Do they have outliers? From my thing is yes. And so on and so forth, right? No, Mary Alert. So yes, so you can email me. I just showed you a link. You can download the Microsoft Office, enter your Hunter emails. So or you can ask James. James is basically that it just type in saying that you can actually get this for free by logging using the Hunter email and the password. Okay, so I think that's is more technical. Getting the SL for free. So it's from the Hunter College, but you can email me again, should you a link for that, and then you can download it for education. Let's see if you can download that. I think I can download this. Yeah. Okay. So let me just close that one more times. And I believe it's free. We just finished the project, correct? So we have any concerns, let me know. So let me just copy the Unicode text if that works on the student. Okay. Yes, so let's save it on the Unicode text and see if we can get it done. Okay, so let's go one more times. JASP. And then if you can't actually use it, open it, and then use your computer, browse my file, and save that word. Yeah, it worked. You can save a text and whatever. So it worked as well. So you can go for the statistics and see. Yeah, it worked for Unicode tests and for anything. Okay, it doesn't necessarily have to be the things. So, or you can just use it save as Unicode. Next. You just have to read the. You just have to read the. You just need to read the file that the JASP going to accept it. Okay, the file that is going to accept it. And whenever you see all of this, it should be done relatively quickly. For a survey, we identified 2 categoricals and 4 measurement method. Which ones? No, for the data days, we need to identify all 13. Name of the variables is just relatively easy for that.
Oh yeah, that's what I mean. So for all 13, right?
All 13, all 13.
Variable, right?
But when we make a chart, we just pick 2 and 2. Okay, 2 categorical and 2 numerical data. Okay, so that's we have to get it done. 2. Is that good? And then make sure that you're gonna make data day. I think you have to make the first page with your names. You can make it look nice when you submit it. So when I read, it's gonna get more points. Okay, instead of me doing that. At Hunter College. I know it's Hunter College. Okay. All right, so I believe that's good for today. And once we come back and we're going to do the exam review and then take the exams. Are we good?
Yes.
Okay, so, and then before we leave, I just want to go over a certain question, just a quick look at it. So the first questions that you may have going to be, you're going to choose the name of the variable, you're going to identify them, whether it's categorical or quantitative or numerical. Quantitative categoricals, which level of measurements that we have. The second question we're going to why we're going to have bias between observational study or the experiments, experimental design. So we have to take care of that. And then Y is going to get some bias for that reasons. And then how we're gonna get over it. So let's say the 7 second resident want to know more about the tower opinion is false, whatever it is, why the rate was so low. And then you have to go for bias. The question 4, you need to know how to read the charts. Question 5 as well. Question 6, identify whether it is symmetrical or bimodal or bear shape and so on and so forth. Question 7, so you see that this is what we have done about these standard leaf diagrams. Question 8, percentage. Question 9, this is the question that we actually struggle a little bit, right? And which one is true, not true. And question number 10 that we have for the data test points there. Question number 11, so we have to look for if we change one of the data set point, what happens to the mean and then the median. Question 12, so we going to look for, so what is the use for that? So the most commons going to be most often going to be the modes. If the data set doesn't jump, quickly for that, it's going to be the mean. If there's one data set just jump crazy, so that the median is going to be used to summarize the data. So 13, the same thing. 13 was hard. You have to answer the questions for that part, and then some mean, median, mode. For all of this is just like the question that we have for the test 1 that we're gonna do next week. All right. So I hope that you guys have a wonderful weekend. Have a study hard for it. Have a wonderful time. So I'll see you guys next
Professor?
Saturday. Yeah.
Professor, please can you go back to the question 11?
Which one?
11,
11.
yes.
11, we're gonna read them. We're gonna read the solution. So if suppose 6161 replaced by 305, what happened? Is it gonna change the means and how much it's gonna change? Okay, so we're gonna read them. Okay. All right. How many questions? 20 questions. I give you 20. What do you mean? I have 20 questions, give you 20. So it's generally for the 20 questions, questions 5 point. Okay, so it's not quite easy to ace all of them, right? So we're gonna do very careful. So we have 20 questions, we have an hours and 15 minutes to get it done. And then, which means that we're going to finish it within an hour and 15 minutes. So that'll be 75 minutes. Each question, we're gonna get 3.5 minutes to get it done. And I hope that it's not gonna be really sad for all of us. So for the attendance, we're gonna do attendance today, and we have, remember the attendance is gonna be part of your grade. So after that, just wanna make sure that we need to do the knowledge check. The knowledge check is not gonna be part of your grade, but you need to take the exam. You have to do all the knowledge check for this. Okay, so make sure that after you finish objective 2, you're gonna get full credit. You're gonna get some, you have to do it today. Okay, if you do it today, if you finish all of this knowledge, you finish objective 2 today, I'm gonna give you another 10% extra credit for that objective. It will be computed at the end of semester. All right, so after that, you're gonna have a post knowledge check. Okay, you're gonna start with this. Okay, and then
And so, Professor, we have to do the post one or the knowledge check because the knowledge check is closed.
yes, the previous one is closed. I actually remove it for the knowledge check once. Was it closed today? No, it's actually not closed. So let me just add it. Let me just change the date. The date should be, I give you 24 hours to finish it. Okay, so we have to finish it today to get another 10% extra credit for the objective. But if you finish it tomorrow, that's fine. And the post knowledge check should be done after this, after objective 2. it doesn't really factor into your final grade. Just want to check out if you are doing it. So it will be considered the edge credit as well. So now we're gonna take attendance. Just want to make sure
Professor.
that, yeah.
Yesterday I had a problem with my Alex. I don't even know why. And I pay for it. I extend the date, but I don't know why it's not working. When I tried to do something and then it said expire.
Oh, you have to buy the code. You have to purchase the
No,
code.
that was yesterday.
Purchasing.
Alex, no, yesterday I was having the same problem. I think
Oh,
most
I
kids are
see.
having the same problems. Alex was having
Oh.
some kind of glitching
Oh.
system.
Yeah, yeah,
Every
yeah. I know,
time you logged in,
it
it
will
would close
Yeah.
your session.
I know.
Yes,
It's,
yes.
it's happening. It's happening for the entire staff 113, not only for your file class. It's like it's happening for another sections. Like a student struggle to log in to do assignments, but they have a little glitch from the system. They fix it. They fix it. The
Oh.
email is they fix it. And then
Okay.
yeah, the people just debating like why it took 25 minutes for a student to log into Alex for that reason. So I understand. I saw some email. I also tell them that, well, you might want to extend to another 24 hours for your student to get his job done, his or her job done for the assignment. So I realize that that's really important. But anyhow, it's happening. You know, sometimes Alex sucks. Nobody wanted it. Actually, I'm trying to remove it. There's so many questions to cover. We're so sick of it, but we have to stick with that because this is it's coming from the lady who taught the course for more than 55 years. So we're gonna respect that. So Shallow is here. Almer is here. Almer?
One of the classmates, she said that she's leaving early, but I
Okay,
tried to
yeah.
look at her message. I couldn't able to find her name and her message.
Oh, so it's okay. I found her.
It start with
I
K though.
Shayla, yeah, I marked her present. I marked her present, Shayla. Yeah, Angelica is here.
Here.
Okay, Ruth is here. Neris,
Here.
got you. Jesse? Jesse is here. Jesse is here. Okay. Andy?
Here.
Maurice here? Got you. Jam is here. Sally is here. Jimmy?
Yeah, here.
Got you. Cecilia? Yes, please add Jimmy to the web app so and see what if someone who can actually download the Excel, Microsoft Excel for our class, so that would be awesome. Okay, so it can help them to download the file. One is here. Haiti?
Here.
Yes. Maria?
Here.
Alex here?
Oh, I'm here.
Okay, Ted is here. Fatma is here. Kiani, got you. The level here. Okay.
Here? I'm here,
Okay, so Sioni's here,
Here.
and yours here. Ashley,
Here.
Avril is here. Maria is here. George, Angeline is here. George is here. Elizabeth is here, right? Amelia is here. Colina is here. Okay, so I hope that all of you are doing fantastic. So George is also here, which might be away. All right, so I hope that all of you are doing fantastic today. So if you have more concerns, more questions, just let me know. So Jazz is really straightforward. Okay, so let me repeat that again. If you have trouble, just do some clicks. Okay, you can try them out. You do a few clicks, and then you should be able to get it done. Okay, the only thing that left is that we're gonna just do some explanation. It should be straightforward. Okay. I didn't hear. I call you. I have marked you present already. Okay. I saw your names on my chat list, so I marked you present. That yeah. So you don't have to worry with this. So and that's pretty much for today. So you have more concern, more questions, just come to my office hour. If no more concern, I'll see you guys I see you guys next Saturday. So remember, the next week we're gonna have the first test, right? We're gonna have a first test. So the test gonna get started at 10 until 11:15, and that's pretty much it. Okay. All right. So have a wonderful weekend, people. Get ready for the test. Just do more practice questions. So go to the exam review and practice on Alex, okay? And it should be all right. Because overall, the system gonna pick the questions randomly, basically coming from the objective, that we already learned. If you learn it, it should be fantastic. Shallow and mark your present, and do not have to worry about that. And say, hope that all of you have a wonderful weekend. Take care.
Professor, real quick. Since
Yes.
we're having that problem, because that problem was happening since the night before, right? Late at night when I was doing my work, and then all day yesterday that was happening. I kept getting just kicked out and saying session closed constantly. Are you gonna extend that?
Which one? The objective.
Objective that till at least because it's due tonight into tomorrow night.
I mark it. I make it due tomorrow night.
Yes, thank you. If you could do-
Yeah, I did it.
I was trying so hard yesterday and it kept.
I
kicking
know
me.
this is what I changed the deadline already. Yeah.
Right, thank you so much.
You're welcome. Okay, so I hope all of you are doing fantastic, and take care.
Take care. Have a good weekend.
Professor,
You
can I
too.
join at 12 o'clock? Is that okay?
Yeah.
Okay. thank you.
12. See you. Yeah. Bye.
Thank you.